today we are going to continue our practice with solving systems by using the elimination method. So let's remember what the solution to a system is. A solution is where the two lines intersect. Where two lines intersect. For elimination, the goal is to eliminate one what? Remember from the previous notes, we are wanting to eliminate one variable and solve for the other. And my question to you is based on yesterday's notes. When do you use elimination? Do you remember? That's right, when the variables or letters are lined up on the same side of the equal sign. So when the variables are lined up on the same side of the equal sign is when you would do elimination, or when it's better to do elimination. So it's asking you to solve each system by elimination here. Number one, first of all, if we look at the x's, are they opposites? No. Are the y's opposites? No. So let's see, what would make the x's be opposites? We have a 2x here, so this one, it would be nice if this one was a negative 2x, because then we could go ahead and cancel them out. And so I think that's what we may go for, but let's look at the y's. Is there anything we could do to the 3 to make it a 4? No. Is there anything we can do to the 4 to make it a 3? No. So I think we're going to stick with the x's here, and we would like for this x to be a negative 2. So remember when we were trying to find the one that's close, we were multiplying by a negative 1 on yesterday's notes. Let's go back and look at that real fast. So on the elimination part 1 notes, if you look back, we didn't have any opposites here, but the 12 ends were close. So we multiplied each of them by a negative 1. It didn't change the value of the equation, it just changed what it looked like so that we were able to cross out the ends. We were able to eliminate the ends. And so right now we are looking again to eliminate a variable, and we've decided that the x's are so close, all we have to have is a negative 2 here for the x. So we're going to multiply this bottom equation by a negative 2. And remember, when you do this, you have to distribute to each number or each term in the parentheses. So what we'll do here is we will go ahead and multiply negative 2 times x, and then negative 2 times 4y, and that's negative 8y, negative 2 times negative 9, that would be a positive 18. Now we did not do anything with that top equation, so I'm going to leave it alone, but I'm going to rewrite it as the top equation. So now we have our new system of equations here. If you look at the x's, we have the ability to get rid of the x's now and add. Okay, so when we add the two equations together, the 2x and the negative 2x will go away. So then this would be a negative 11y when you add it, and this would be 22. Now we can divide by negative 11, and y is equal to negative 2. Now, is this my final answer? No. Remember, a solution is where the two lines intersect, is a point. And so that point has an x and a y. Well, at this point, we only have the y, which is negative 2. We still have to go back and figure out what the x is. Do you remember how to do that? Right. Go back to an original equation. And so that top one was original. So we're plugging back in, and I'm going to write this down, plug in to original equation. And so I'm going to rewrite it, 2x minus 3y equals 4. And so in place of that y, I'm going to put a negative 2, because we now know that the y is a negative 2. Okay, at this point we're going to go ahead and simplify. This negative 3 times negative 2 is positive 6, and we'll drop down the 2x and the 4. Then remember, we're going to subtract 6 on both sides, and 2x equals negative 2. If you divide by 2, then x equals -1. So we have now finished our solution by writing in a -1, -2 for the solution. These are where the two equations are the same. So let's go back and just double check what we did. We noticed that in our equations we didn't have any opposites. So there were no opposites at the beginning. So because there were no opposites, we look at each letter. You look at each letter and decide what the other letter needs to be, and decide what you need. So in this case, we needed a -2x to cancel out with a positive 2x. And so when we decided what we needed, we just multiplied your equation by what you need, and then you just go to town solving. Okay? So let's go on to the next one. Number 2. We have 4x minus 5y equals 23 and 3x plus 10y equals 31. Now as we look at the x's, we don't see anything that's the opposite. On the y's, nothing that's the opposite. And so we now have to decide, okay, what do we need? And if you look at the x's, there's nothing I can multiply by the 3 to get me 4, nothing I can multiply by the 4 to get me 3, but let's look at the y's. Is there something you can multiply by the top one, the -5, to get me 10? Yes, I need this to be a -10y, right? So if I need this to be a -10y, what would I need to multiply that top equation by? So we're going to get rid of the y's by doing what? Multiplying that top equation by a 2, because we need a -10y. Let's write that underneath. So we're going to get rid of the y's by multiplying by 2, because we need -10y and positive 10y. There we go. So we're going to get rid of the y's by multiplying by 2, because we need -10y and positive 10y. So let's go ahead and distribute. 2 times 4x is 8x. 2 times -y is -10y. 2 times 23 is 46. I'm just going to rewrite that other equation down. 3x plus 10y equals 31. Do we have opposites now? Absolutely. So whenever we go to add them, the 10y and the -10y will cancel. 8 plus 3 is 11x, and 46 plus 31 is 77. Now we just solve for x. So we can divide by 11, and x is equal to 7. Am I finished? Nope. We've got to get our x and our y, and at this point all we have is the x. So how do we go back and get the y? That's right, we plug it back into an original. The bottom one is original this time, and so we will write 3x plus 10y equals 31. Where are we going to put the 7? In for the x, that's right, because it says x equals 7. So we'll do 3 times 7 plus 10y equals 31. Now we simplify and solve. 3 times 7 is 21. We can subtract 21 on both sides. So 10y is equal to 10. Now we can divide by 10, and y is equal to 1. So here we put a 1 in for the y, and we are finished. The solution to this system is 7, 1. Moving right along, looking at number 3. Are the A's opposites? No. Are the C's opposites? No. Well, let's look at the A's. Is there something you can multiply by 3 to give you 5? Or 5 to give you 3? No. Is there anything you can multiply by the 4 to give you 9? Or the 9 to give you 4? No. Well, that's a problem. Any ideas on what we might be able to do? Maybe you could multiply both equations by something. If we wanted 3a and 5a to cancel out, what would the magic number be? What would they both need to go to? This one, yes, to get rid of the a's, we need a positive 15a and a negative 15a. So all we have to do is decide which one we want to be a positive 15a and which one we want to be a negative 15a. Let's make the top one be positive. So if I want the top one to be a positive 15a, then I would multiply the top equation by 5, yes. So 5 times 3a is 15a. 5 times 4c is 20c. And 5 times 2 is 10. Okay, now let's go ahead and do the bottom equation. Now the bottom equation, since the top one is a positive 15a, we need the bottom one to be a negative 15a. So what would I need to multiply the entire bottom equation by to make this a negative 15a? Negative 3. Good. So then we're multiplying negative 3 times 5a, that's negative 15a. Negative 3 times 9c is negative 27c. And negative 3 times 1 is negative 3. Now we can add these two equations together, and the a's will cancel because they are opposites now. So now we're going to add these two together and get negative 7c is equal to 7. Next we divide by negative 7, and c is equal to negative 1. Am I finished? Nope. We've got to make this be, we've got A and C over here. So A comes before C in the alphabet. So we're going to put the negative 1 in the second place of the ordered pair. And how do we go about finding what the A is? That's right. Plug it back into an original. And I'm going to go way back up here and I'm going to plug it into an original. I will write down 5A plus 9C equals 1. Question is, do we have to use the bottom one or can we use the top one? You can go back to either one, that's right. So 5a plus 9, remember I'm replacing the c because it says c equals negative 1. Now we simplify. 9 times negative 1 is a negative 9. Then we're going to add 9 to both sides. And this is 10. Divide by 5 on both sides, and a is equal to 2. So 2 negative 1 is our solution to the system. All right, let's look at number 4. Do we have any opposites on the p's? Nope. How about opposites on the q's? Nope. So that means that we're going to have to find the magic number. What's the magic number for the p's? 12, that's right. So we want to get rid of the p's. We need positive 12p and negative 12p. Well, we've already got the positive 12p, so what does that mean we need to multiply the top equation by? A negative 3, that's right. So then we're going to distribute negative 3 times 4p is negative 12p. Negative 3 times negative 5p is positive 15, excuse me, that's a q, 15q. And negative 3 times 3 is negative 9. Did we do anything to that bottom equation? No, and we don't need to, so we're just going to rewrite that one. So then we add, and when we add, your 12 and your negative 12p go away. But look, 15q and negative 15q are opposites too. So that's going to give me 0 on that side. Well, wait a minute. Negative 9 plus 9, that gives me 0 too. So 0 is equal to 0, and the letters have gone away. What does that mean my answer is? Is this a true or false statement? This is true, so my answer is infinite solutions. Or you can put the all real numbers sign. All right, let's go on to the last one. Do we have opposites for the m's? No. Opposites for the n's? No. Okay, let's go ahead and try to make one of those letters eliminate, or let's get rid of one of those letters. So what would be the magic number? And let's go with the n's this time. It doesn't matter. You just choose one and you go with it. So I'm going to make the n's go away. So to get rid of the n's, what's the magic number? We need negative 10n and positive 10n. Right now we have a negative 10n, so what does that mean we need to do to the top one? Multiply by 2, that's right. So then 2 times negative 2m is negative 4m, and 2 times 5n gives me 10n, and 2 times 2 gives me 4. Did I do anything with that bottom equation? No, so we're just going to write that one down. Now we add. So negative 4m plus 4m goes away, but wait a minute. 10n and negative 10 goes away too, so this gives us a 0 again. But 4 plus 2 is 16. Is this, since the letters have canceled out, you have to see what you have left. Is this a true or false statement? This is a false statement, and so because it's false, your answer is no solution. So remember, each time we were looking to get a magic number. Here the magic number was a negative 10 and a positive 10n. Here the magic number was a 12p and a negative 12p. Here the magic number was 15a and negative 15a. What would have been the magic number if you wanted to get rid of the c's? 36c. That's right. You would have had 36c on top and a negative 36c on bottom, or vice versa. And so you would have had to multiply by the right number to make the 36c happen, that magic number of 36c. Let's go back to the first couple and see what the magic number was there. What was the magic number on number 1? Which one did we get rid of? We got rid of the x, so the magic number was a 2x and a negative 2x. On number 2, what was the magic number? It was a 10y and a negative 10y. Okay, so we're looking for a magic number so that we can eliminate one of the letters and then solve to get both your x and your y, the first and second coordinates. Good luck on elimination part 2. Have a great day.